So you thought your days with long division were over in elementary school, huh? Well, guess again. Long division is back with a vengeance, now in your algebra class. We're going to review how to do long division with polynomials now. But before we do that, let's go over what is long division. It's likely been a while since you've seen it. Long division is when you take a dividend, let's say 1726, and you divide it by a divisor. And you say 5 can go into 1 how many times? 0. 5 can go into 17 how many times? 3. 3 times 5 is 15. Is this looking familiar? You bring the next thing down. What I want to do is challenge the way that you ask yourself the questions. Instead, I want you to say 5 times what would get me as close to 22 as possible without going over. 4 times 5 is 20. Change that sign and add and bring the next number down. 5 times what would get me close to 26? Write that down here, change the sign, and write the remainder. Your final answer, or what we call the quotient, is going to be 345. You take the remainder and put it over the divisor. That should hopefully look familiar to you. I want to also review with you quickly what is a polynomial. If I had 7, that would be considered a monomial, and 2x would also be a monomial. And if I wrote 3x squared, that would also be a monomial. But when I put a plus or a minus sign in between monomials, I now form a polynomial, and this polynomial is in standard form. It goes in decreasing order of the exponents. So today we're going to be doing long division with polynomials in standard form. Let's go ahead and start with the first example. There we go. All right, so we have the dividend, x cubed plus 3x squared minus 4x minus 12, which is being divided by the divisor, x squared plus x minus 6. Here's how I want you to ask yourself the questions. X squared times what would give me x cubed? The answer is x. Now, just like in long division, you're going to multiply that x by the x squared, but also by everything else in the divisor. So x times x would give me x squared. X times negative 6 would give me negative 6x. Now I'm going to change the sign of everything in this row. So if it's a positive, it becomes negative. If it's a negative, it becomes positive. If you do it correctly, your first term should cancel, and then you add straight down. Whoopsie. And this would be a positive 2x. Then you go ahead and you bring your next term down, and you repeat the question. X squared times what would give me 2x squared? The answer would be 2. You go ahead and you multiply those together, but then also distribute that 2 to everything else. And just like before, you need to change the sign of everything in that row. If you do it correctly, that first term should cancel, and you're going to notice that so do the other terms, which means we have a remainder of 0. So what this is telling us is that when we divide the dividend by the divisor, we result in the factor of x plus 2 as our quotient. Let's take a look at another example. In this case, it's a little bit different because back here I didn't have a coefficient in front of the divisor, and here I do. But the process is still going to be the same. My first question is 2x times what would give me 2x to the 4th? Not a 2, just x cubed. We go ahead and we multiply those two, and we multiply that x cubed by everything down there. We change the signs of everything in that row. The first terms cancel, and we bring down the next terms. Go ahead and bring the next as well, and you repeat the question. X squared times what would give me negative 6x cubed? That's going to be a negative 3x squared. Go ahead and distribute that across. Oh, wait a minute. That's my clue that I'm doing something wrong. Negative 3 times 2 is negative 6x cubed plus 9x squared. Go ahead and change the sign of everything down here. So we had a positive 21 and a negative 9. That's going to leave us with a positive 12x. Go ahead and bring down the next term. Getting a sense of the pattern here? We ask ourselves, 2x times what will give me 12x squared? That's going to be 6x. Go ahead and multiply. Make sure that you change everybody's sign down here. That's going to leave us with 8x. Oh, negative 8x. Watch out. Bring down your plus 12. And for the last time, 2x times what would give me negative 8x? That would be a 4. Go ahead and distribute that across. Make sure you change everybody's signs. And in this case, everything cancels. We have a remainder of 0. Now, so far the two examples I gave you turned out real nice. We had a remainder of 0, and in the beginning, that's how your problems will work out too. But as you get better at this, you'll start seeing situations where the remainder doesn't turn out so nice, but our technique is still the same. Let's check out this one. I ask myself, 2x times what would give me 2x cubed? That's going to be x squared. Go ahead and multiply. Change the signs. Add straight down. And then bring down the next term. 2x times what would give me 4x squared? That's going to be 2x. Go ahead and multiply. Make sure you change the signs. And bring down the next term. Let's change the color. 2x times what would give me negative 4x? That's going to be negative 2. Multiply everything. Change the signs. And here we have a remainder of 15. If you remember when I showed you the long division refresher, we took the remainder and we put it over the divisor. So in this case, our final example, our final answer will be 15 over the entire divisor. And then we just put a plus sign to connect them. I know it looks weird. Your answer is x squared plus 2x minus 2 plus the fraction of 15 over 2x plus 3. As weird as it looks, that's it. Get used to it. Let's try another problem. Sometimes you are presented with the problem that's in a different format. In this situation, they may actually write it as a division problem. So you can see here that we have it written out with a division sign in between. In the beginning, I mentioned to you standard form, and that's when the exponents are in decreasing order. And while x cubed plus 2 is in standard form, and so is the entire dividend, they're missing a few key elements. For instance, if you look at the dividend, we have a power of 6, power of 5, but we're missing the power of 4. So when you write it in the division, you need to make sure you fill it in with a 0, x to the 4th. When we're looking at the divisor, we have power to the 3, but we're missing the power to the 2 and power to the 1 before we got all the way to the constant. So anytime you're missing a term in your polynomial when it's in standard form, you need to make sure that you include that with putting a 0 in front of it. If you don't do that, you're going to get the complete wrong answer. So it is a key step in catching the situation before you begin the problem. Now that we've filled in those with zeros, watch what happens here. Same process. What times x cubed would give me x squared? That's going to be x cubed, because when you multiply base terms with the same base, you actually add the exponents. So go ahead and multiply across. You're going to see some funny things happen with these zeros, but that's okay. Notice everything is matching up the way I would like, which is a good clue that I'm doing something right. Make sure you change everyone's signs. Yeah, I know the zeros don't really matter, but let's just get in the habit of it. And then go ahead and add straight down. Again, the zeros don't matter. but we're going to include them because they really do matter. Now we're going to bring this down and we repeat our question. X cubed times what would give me 2x to the 5th? That's going to be 2x squared. We're going to go ahead and distribute that across, even to the zeros. 4x squared. And then we need to make sure we change everybody's signs, even those zeros. So we bring everything down. I know it seems weird to write that 0, but trust me, you don't want to leave anyone out. I'm even going to write it here. Oh man, another 0. Okay. X cubed times what would give me 0x to the 4th? Well, it's going to be 0x. Go for it. Multiply across. Got a whole bunch of zeros happening. Don't even really need to think about it. 0 times anything is 0. You do have to make sure you change everybody's signs just to get in the habit. Anything that's a 0, keep it written there, please. And we'll write the last one. And we ask ourselves the question one more time. X cubed times what would give me 3x cubed? That's going to be a 3. I got to get myself a little room here. Go ahead and multiply across. And then make sure you change everybody's signs. That cancels, and since we're all done with everything in the dividend, we can just do a big old cancel party and don't have to write the zeros if you don't want to, because we're at the end. And that is your final answer with no remainder. Now, if you want to write it nicely, you can rewrite it without that 0. So really your final answer would be x cubed plus 2x squared plus 3. That 0 is a placekeeper for us as we're doing the long division, but in our final answer, you don't have to write it. Now, for the last problem, let's talk about what happens when you have missing terms and you fill them in, and then what happens when you still get a remainder. We're going to combine everything together so far in one awful problem. Just like before, it could be written with the division sign or it could be written as a fraction, which implies division. Just make sure that whatever is written first or on top goes inside of the division sign, and whatever is written second or on bottom goes on the outside. Also, always double check that you have everything there in your standard form. If you notice on the top in the dividend, we're missing our x to the power of 1 term. So we want to make sure we include that with a placeholder of plus 0x. Now we go through our normal strategies. What times x squared will give us x cubed? This one isn't so bad so far. You know what to do. Make sure you change everybody's signs. So that's going to leave me with a negative 10x squared and a minus x. And then don't forget to bring down the negative 42. We're already at the end. That was fast. X squared times what would give me negative 10x squared? Go ahead and multiply across. Make sure you change all their signs. So that's a plus, that's a minus, that's a plus. And then you go straight down. So we have negative 21x, negative 32. Now, just like before, when we're writing our final answer, we put a plus sign, we take our remainder, and rewrite it over our entire divisor. That's a 1, trust me. And that is your final answer. So, a few things to just keep in mind. The way that you word your questions makes it helpful. So ask yourself, what times this would give me that? And then make sure you distribute it. The other thing to be really careful about is that you're changing the signs of everything in the row before you add down. If you have any other questions, feel free to contact us. I'll have the links for our website and our Facebook and all that other good stuff down in the notes below.